Hi everyone, today we are going to talk about acceleration. You may say it is a very simple concept, but in this lesson, I will tell you that it gives you a lot more than you think. From the concept and equation, it's easy for you to decide speed after a few seconds. For example, the car has 15 kg per hour per second. Based on that, we can say after 1 second, the speed is 15 kg per hour, and it's easy to tell after 2 seconds, after 5 seconds. But what else? Actually, the first, it tells you the direction of the velocity in every second. We still take the car as an example. Why the car still moves to the right after 5 seconds? From the equation, acceleration and the change of velocity always have the same direction. Thus for the car, for every second, the change of velocity points to the right. The change of velocity is equals to the final velocity minus the initial velocity. Keep in mind, both velocity and acceleration are vectors, so it follows the rule of vector addition. We use tail points to the tip, thus points to the right. So in every second, the final velocity is pointing to the right. 我们看第二个例子，加速度垂直于初速度，同样进行等价，加速度的方向为 delta v 速度变化的方向。根据概念 delta v 等于末速度减初速度，然后我们把末速度提到一边，通过矢量三角形求和得到末速度的方向。所以物块会斜向下运动吗？ Another example, acceleration is perpendicular to the velocity. Say we have an elephant, he wants to move forward, but the acceleration is downward. So what direction the elephant will go? Still based on the equation, the acceleration downward, then the change of velocity also downward. Let's calculate the final velocity after a period of time. As shown in the red line, does it mean that the elephant will go the lower right corner? The answer is no. Let's take the first period of time is 1 second. Thus, the red arrow shown the velocity is after 1 second. Now let's see what happens after 2 seconds. Because the initial velocity has been changed to the velocity after 1 second, we can see the direction of velocity keep changing. If we trace in every second, we will find out the trajectory is looking like a parabola. And yes, it is projectile motion. Now we understand why the velocity along the tangential acceleration. Now let's move to number 2. It also tells you how the magnitude of velocity changes. We normally use the component's velocity to decide. The horizontal component is constant. The vertical component increases at the constant rate under the influence of gravity. Thus, the resultant velocity will increase. But now I will tell you a new way to decide. By using the components of acceleration. Here we have 2 components, parallel component and perpendicular component. It indicates parallel to the velocity and perpendicular to the velocity. The parallel component is responsible for changing the magnitude of velocity. The perpendicular component is responsible for changing the direction of velocity. In the shown case, we have perpendicular acceleration, so the trajectory will keep changing, the velocity direction will keep changing. We also have the parallel component, that it has the same direction with velocity, thus the speed will increase. We got the same result. Finally, there are some questions for you. If you want answers, want resources, want more classes, please join the QQ group. I'm always in the group waiting for you. Believe me, it's worth it.